What if straight lines couldn't exist? This, and this. These are all examples of straight lines, but what is a straight line, and what would life be like without them? Welcome to Here's My Theory. A straight line, by definition, is 2 points and all the points in between them. There's actually lots of different types of lines which are portrayed differently on a graph. Today, we'll only be talking about lines with a consistent gradient, lines that start straight and will infinitely be straight. To learn about lines, first we need to think a bit about geometry, specifically Euclidean geometry. In 300 BC, my main man Euclid devised a set of rules that everything had to follow on a flat, two-dimensional plane. These rules, simplified, are as follows. 2 points can be joined by a straight line. Straight lines can be infinite. A circle can be constructed when its center and radius are defined, and all right angles are equal. It's virtually impossible to imagine a world where none of these explicit rules are true, but let's hypothesize. Let's say in some instances, 2 points cannot be joined by a straight line. If for some reason there are some points that can simply not be joined by straight lines, that means that straight lines cannot be infinite because at one time or another they shall reach this hypothetical barrier that prevents them from being straight. Then, no longer can a circle always be constructed, because if it reaches this hypothetical point of inaccuracy, the radius cannot be straight and therefore the circle cannot be accurate. And finally, if sometimes a right angle is created in this point of inaccuracy, its inability to form straight lines means that a right angle in this area is different to a right angle in another. This is all 2D, but it's surprising to realize the amount of effects it would have on our lives. For example, no longer would architects be able to rely on paper and 2D planes to envision their designs. The lack of any consistency would also prohibit mass machinery to operate as it does currently, meaning that they'd have to create a template of an object and copy that instead of simply using basic geometry. Any measurements would become obsolete because there would always exist an environment where those measurements would be inaccurate. So much would change, in fact it would be easier to list the things that wouldn't. But the thing is, as three-dimensional objects living on planet Earth, we actually don't live in a realm defined by Euclidean geometry. Sure, a lot of modern day technology relies on it, but Los Angeles and Paris cannot be joined by a straight line. We live in a non-Euclidean world. On planet Earth, 2 lines that pass through the center cannot be parallel because they will inevitably intersect. This is the rule of elliptical geometry. Although our Earth is not a perfect sphere, all of the hypotheticals following elliptical geometry apply to us. However, even though to make something perfectly level, it has to reflect the curvature of the Earth, making something perfectly level has almost no impact on us as humans. I doubt anyone, except for Morty, of course, has experienced perfect level, and if they have, it's by pure chance, and they wouldn't have noticed. But then, that begs the question, if our houses are made of straight lines, surely the lack of any straight lines would instantly demolish all of our houses, and all existing structures would be unstable. This is the point where I shall introduce atoms. Atomically, most, if not all, of our so-called straight lines are not actually straight. Atoms don't have a side that's a straight line, so all surfaces are rough because the way atoms line up means that there's a minuscule amount of space between the edge of an atom and the edge of another. And this matters so incredibly little to us, yet it means, in theory, we live in a world where straight lines do not exist in objects. All existing structures have different right angles simply because we don't literally define a right angle as 90 degrees commonly. We can build almost anything with a 90-degree angle, but adjust it by 1/trillionth of a degree, and nothing would change. Some situations require pinpoint accuracy that only machinery can grant, like crafting a space shuttle or microtechnology. But even in these situations, an offset by a number so infinitely small is still an offset, yet it would be considered accurate. So we've established the inexistence of straight lines would have little to no impact on our building and production. You can live in a house with a slightly bent wall at a slightly acute angle and fail to notice. In fact, we haven't even created technology to measure something that's infinitely small, which means that all of our measurements are slightly inaccurate. And when I say slightly, I mean by such a small number. If you got our best microscope, you still couldn't see it. By now, you're probably thinking, right, I get it. A perfectly straight line and an imperfect line are pretty similar if the imperfection is minimal. But I've got one more curveball here. Physics. Majority of physics would be instantly disproven. Note here, space-time seems like a bit much, so we're going to go ahead and steer clear from that for the time being. Picture this, you're running towards a finish line. You can see it, it's right in front of you, but you trip, oh no, and you fall to the left. But here's the thing, you were pushed to the side, not by anyone, but by gravity. First of all, what is gravity? Gravity is the force that draws you to the planet's center. The pathing it takes is the most direct, as it's a force, so no obstacles we know of prohibit it from taking a straight line right into the center. We don't know a lot about gravity and what it exists as, but we know what it does, which is enough to base my speculation off. The force of gravity, instead of going directly down, went to the left, and the sudden shift pushed you. Imagine a world where at every single instance and location, the direction of gravity was slightly different. We'd hope to presume that at a majority of the instances, gravity would force you down at a very slight angle. As a matter of fact, that's what it might be doing. We just don't know that yet, because all science is a theory. But in our hypothetical world, the absence of straight lines means that gravity can no longer create a direct path to the center of the planet. Even though gravity is a bit wavy and wobbly, the center of the Earth is still the target. But since there's no straight lines, there's no guideline for gravity. Think of it like this. Right now, in our Earth, gravity is going directly to the core. But in our hypothetical Earth, it cannot go directly, so it has to do anything but that. And since gravity isn't conscious, it can't create a template line and follow that at every single place on the Earth. Gravity has to guess the most direct way to the core of the Earth with no reference and no way to reach there directly. Now here's where it gets wacky. Our current universe is constantly expanding, so it's infinite for the time being. Infinite for the time being. That'd be a nice t-shirt. So this means that gravity has infinite possibilities of its line creation to get to Earth. So if no other planets existed, we'd always be flying around to random points in space until we eventually land on Earth, most likely dead. But since there are other planets with a stronger pull, we'll eventually reach a point in our voyage to Earth that will be intercepted by another planet and be pulled in to eventually land there. And so the journey continues. We'd be constantly floating in space and the force of gravity would be a randomized mess. Now it's your turn. Go ahead and learn about some sort of sciencey concept that relies on straight lines. Light, momentum, the mathematical theory of numbers, time, x and y axes, constant temperature. Then guess at what life would be like. Nothing could be consistent anymore. Everything would gradually increase or decrease. Numbers would no longer count by 1. Instead, they would count by 1 and one infinitely small decimal place, so that after infinity, one number would skip a number. There would be a number that could not exist. What chaos! What a world! What would happen to everything? It's quite literally inconceivable. It's impossible to imagine. Let's suppose that the multiverse exists. If you're unaware of this theory, it suggests that our universe is one of infinite universes with different laws. That means that this world would certainly exist. A world with no Euclidean geometry that defies all logic we live by and has an unfathomably different experience in life. So, what if straight lines couldn't exist? We don't know. It's such a core concept of so much we live by that our only answer is to simply theorize and get nowhere. It's impossible for me to express how different our lives would be. This is not to say that they would or wouldn't be drastically different, it's just to say that we don't and most likely will never know. And what does that mean? It means you just spent 8 minutes of your life listening to hypotheticals. But it also means you have a better understanding of the world around you, and that is ultimately my goal. Thanks for watching, liking, and subscribing, and if you have any ideas for more content, feel free to comment down below. And most of all, have a good day.